Okay, here we go. These are our notes. We're gonna go on. So you're down in They should be page 53 in your handy dandy notebook. So you need to make a note to yourself. These are what page? 53 in our handy dandy notebook. Okay.
I asked my grandma if she's ready to die. She said she's still in there.
All right.
Bro, you're
That was part 2. And part 1 was 51.
You're not sending all business.
All right. We're on part 2, which is going to be 53. All right. Part 2, determine the image of multiple points. So our objective here is to use 2 by some unknown number matrix to represent the coordinates of points and discover that representing multiple coordinate pairs in a single matrix allows them to efficiently determine the image of points spontaneously. Basically, our job is to figure out a shortcut to find the transformation of multiple points, right? All right, so before we get started though, I want you to dust off your brain from last week and the week before and transform these 4 points, okay? So we are given our coordinate function. Remember, this is called a coordinate function. Coordinate function. Coordinate functions are written in standard form of ax plus by. I started grading some of those quizzes and I see that some of y'all forgot what coordinate function meant. But coordinate function meant that it's in ax plus by form. Okay. So using the given coordinate function, you're going to transform and graph the following 4 points of this parallelogram. Cool. All right, so you have 0, 0, 3, 6, 4, 2, and 7, 8 is 2 minutes of fair assessment to transform all 4 points using the coordinate function. And what are we doing to transform? We're plugging in. Y'all are too young for that, but my teacher sung it all the time because there was commercials for plugins. There's commercials.
Like
Outlets, like outlets for air freshener.
I could have put it.
So again, you're too young to understand the song for the commercial. Depressing. Talk it out, work together, check with each other.
Lock it out.
Are you gonna Yeah.
Come on. Everything up here, right? Like bigger.
Hurry up, Randy. I got stuff to email her. So. I'm not looking for these chairs. Well, is it right?
I can do that.
Oh, wait, huh?
Like, plug in.
Check your math on 3, 6.
So I did it right.
Yeah.
Oh, okay.
Steve, right again. Yeah. Yes, you have the 2 times period. And then no 3 times 8 is. Yeah, you could have. Well, 3 times 6 is 18 plus
Take this. You're plugging in for X and Y. Multiply out. Negative. 3 times 6 is? 18 is. Yeah. Yeah, I was like, I didn't see them all.
Just massive.
You guys put together, but they're connected.
My brother wants to go to the beaches and go line. Can you bring over there?
All right, guys, we're gonna checkity check. All right, ready to check? All right, so really quick, the one that didn't move was what? What didn't move? The origin, okay? That's part of our linear transformation. Origin will stay the origin, right? And that's because if I plugged in 0, is that gonna make a difference?
No.
No. So this point is still gonna be here. Make sense? So that's still here. 3, 6. When I plug in 3 for X and 6 for Y, I have 2 times 3 is 6, Miss Jones. I have 3 times 6 is 18. And what do we get? 24. Now, with that being said, can I plot any of this on here?
No.
It's too big. We can't plot these points. Something attacked me.
My pin.
Oh, okay.
Uh,
All right, next. Where would this one be going? Where would my Y go? So now you're going to plug in X. We get 3. 4 times 6 is 24. And 3 plus 24 is 27. So this point would be moving to 24, 27. And can I plot that on this graph? No, I couldn't. But this is going to be its transformation. And then I continue. What will be the transformation of this? 2 times 7 is 14. 3 times 8 is 24. What is 14 plus 24? Huh? 42. These aren't trick questions, guys. I'm not trying to catch you slipping or anything. Okay. 14 plus 24 is 38.
yeah. Yeah, I think I was like, hold on.
Like, wait, that's 38.
Oh, okay.
All right, now we're gonna plug in 7 for X. 4 times 8 is 32 plus 7 is 39. That's where it becomes. And then next one. 4 times 2 is 8. 3 times 2 is 6. What's 8 and 6? 14. 4 is 4. And then 2 times 4 is 8. 4 plus 8 is 12. These aren't trick questions, guys. Okay, I'm not trying to trick you. Just wanted you to multiply. All right, so again, using coordinate functions. This is what your quiz was over last week. Using the coordinate function. Okay, all right. Yes. Now, you're like, man, there has to be another way. So questions we're asking ourselves. Determine the images of the parallelogram. Why is it sufficient to just determine the images of 4 vertices? Well, it's sufficient because I could take each coordinate and just plug it in, right? That's easy enough. Okay. However, is this process sufficient overall? What if it's not just a parallelogram? What if I have a pentagon? What if I have an octagon? It's just plugging in every single point. Is that going to work? Yes, it will. But it's going to become very tedious and maybe not as efficient. Okay. So what we're going to do is we're now going to learn a more efficient way to use a matrix representation of a linear transformation. Okay. So again, matrices were created to make it easier, to simplify it, right? And so we're going to do a couple tests to determine which setup of matrices will give us the answer we need. Okay. So at your table, you're going to divide it up. And we're going to see matrices can have any number of rows and columns. So we're going to look here. And y'all are gonna decide who's gonna try option A, option B, option C, and option D.
I think
Option C will result in the same answer that we got in practice one.
I get it.
Okay, so divide up who's gonna get which one, and then test it. There's two of y'all.
I'm gonna give it the.
On your. Remember that's the purpose of your email was decide which method first. So your J-Tel, your Desmo, or my. If you have one, and then test it out. We already know what the answer should be. Which one of these results is gonna give us our answer? Yes. Grab the pad. Keep the phone. The phone is up there. Sure. On the back of the door.
We're gonna have a 2x4 on the.
Miss Jones, I'm not gonna lie to you, I forgot what shift I already signed up for, can you check? After the class?
If you signed up just now,
Yeah, I just did it.
it should have been an email telling you what you signed up for.
No, they're the same.
But there's different.
I know I signed up for it tomorrow morning.
Focus.
Well, what'd you do?
I'm already done.
That my answers are the same as the points.
Which one are you doing?
Right?
Yeah, I'm doing B. This is multiplication. Oh, yeah.
They all are.
Remember, if it's next to each other, it's 5 matrix multiplication.
like to say,
Can I just rewrite it?
what's its debate?
Right when you put your answers.
1, 2, 3.
Yeah, no. What'd you get, C? I did D. Oh, D.
I didn't see.
621, 4 to 0. But there's no 6 on here, right? I think where it is, that.
What did you do here?
So I'll have to add another line. What if I had? Yeah. No, it's not.
Different so bad, but
Wants to be green.
So did it work?
Yeah.
Show me where you're pointing at.
Oh, if it worked, that would be, then you would get.
If it worked,
If
then
it
we
worked,
How do we do it?
what the games.
Now, this is 24.
Okay, hop on that. Well, I'm gonna do it. I'm gonna do it for you, bro. Oh, you know what?
Work. How do we? Yeah, I did.
You know why?
Work on 14 and 12.
I think fine.
3, 1, 4.
I don't know what.
3, 1, 4. Oh, wait, maybe I did.
Baby, it's okay, cause I can get mad.
No.
Okay.
It worked.
I'm gonna type it. It is 31 days. I don't know what to do.
Oh, wait.
What went wrong?
That makes 21.
I don't know where you got that.
14 and 7.
Yeah.
I got 31 days.
I don't know how you're defining it. Okay, I see it. I see it.
Okay, this is how it looks.
You found that to be efficient?
Whoa.
Okay. Alright, so as you finish up, you're gonna discuss with your table. What did your outcome look like for each one? What's your A?
Oh, we must have had it.
So what does your output look like for each one?
This is B. But they're the same.
Okay. Ah.
2, 3, 1, 4.
So, you know,
D.
longer explanation. Where you go to decimals?
What I'm saying is the same thing. How can we be like?
And you get input. 1, 2, 3, 4, 5. You got 8, and then A, 2 by 2. And then you make fix the B, C, D, and the next C, D,
That's not gonna help.
You're determining which one you're going to do.
What are we trying to find here? Oh, we're trying to find a 20, 25%. Yeah, to see if, yeah. In that case.
D was missing something, right? Instead of parallelogram, D was missing.
6, 12, 24, 0, 0, I got 0, 0. I think.
Yeah.
Everyone.
Yeah. Okay, you can notice there, you have to add. The result.
It's an issue.
Yeah, add in that order. Yeah.
It's definitely not me.
So compared to this, out of the 4 options you have.
And I don't think it's a, because you have to plug in every single individual.
B does not work, it's just different order, right?
I think it's C or.
Options, you want to-
Is it? I feel like, yeah. And then what are basically.
I remember that's what I remember, that's how it was, look at my face.
I got mad, I was gonna lock you out, I gotta get in, I gotta watch the video count.
I think it's really.
Yeah, when I logged in, you were like, yeah, log.
No, I wasn't.
Yes, you were, when I logged your account, you're not.
I was doing the thing because like, you know, did you like watch videos of it? I was like, at the end of it, there was like a little time.
Three
I was waiting for the
plus
timer to
three
finish.
plus six.
Then you lock me.
Remember, all of the row.
You're the love though.
Or you're using.
Yeah, just that little time, it shows just so many minutes.
Oh, sorry.
So, yeah.
Yeah, look, I love the combos that were happening, the questions being asked. All right, did all these work?
No.
Okay, what didn't work?
B.
Why did B not work? It's a triangle. You're missing a point, right? Instead of a parallelogram, you were finding a triangle. So option B did not give us all 4 of our points, correct? All right. Did option A work?
Yeah.
Yes.
Option A did work, but that was a lot to put in, right? Matrix, here you had to put in a 2 by 2, then a 2 by 1, and then a 2 by 1, and then a 2 by 1. So was that necessarily more efficient?
No.
No. What about C and D?
Great,
Were they efficient?
yeah,
Or are they doable?
yeah.
Yes. So option C or D are the most efficient ways to find the coordinate of a transformation of transform points. Okay. The key thing here, remember or note, is that does order matter?
No.
No. The only order that matters is your transformation matrix. So your transformation matrix must be in order. Okay. That must be first and it must be in order. Okay. So remember, this was my 2x plus 3y, my 1x plus 4y, right? That order must not change. Got it? Next, here, it doesn't matter about the order, but the vertical matching must be correct. Order doesn't matter, but your x's and y's must be paired up vertically. Okay. If not, then you will mess up. Got it? All right, so let's go to practice 3. So based on what we learned in practice 2, you're going to transform this triangle ABC. First, you're given a linear transformation. Why is this linear and not coordinate? Why is it a linear transformation, not a coordinate transformation? Not that it's not about the origin. It's not simplified. It's not in the format. Coordinate transformation means that it needs to be in AX plus BY. So before you even create your matrix, you have to write this in coordinate transformation. Okay. So before you can create your matrix, so you're gonna figure it out and then decide which one is the right setup, A, B, C, or D, or E, to solve your points. All right, and go.
Because A is the most complicated, or B and E are
Well,
the.
A,
right
B,
way,
C, or D.
Right, And then E, it has a flip.
Or E.
I mean, E. C.
I don't understand. So the first thing you have to do is change this from linear transformation to coordinate. So we did that. In the very beginning, boom, so we took the linear transformation, we wrote the math coordinate. In order to do that, we have to look at minus AX plus BY. So you're taking this, you gotta write in the form of AX plus BY, so you need two. So what have to do? So the first thing I need to do is what? So looking at the first ordered pair here, what do I need to do?
Fine.
You need to do something. I need to switch these two around.
Oh, no, that's right.
Negative one. There you go, so it'll be 3x minus y. And then in the second coordinate, what do I need to do? You have to. I need to distribute, so I'm left with. Okay, so now that I have my coordinate, I can now create my matrix. So what's my matrix for this? Your matrix are your coefficients, your coefficient. No, they go together. And it'll be. Going two. So now, I know that the first thing I'm multiplying by has to be my coordinate matrix. Then, now you're onto your point.
Yeah, you have everything.
So now, remember, it's vertical, so the first one. Yeah. One and two, then.
Oh, I remember busted screw.
So you know that out of your options here, which one of these are you using? That looks most like what you have. Could you use A?
Yeah.
Yeah.
Oh, any one of them.
Which one? Well, there's two of them.
Oh.
Mhm. There you go. Order of the coordinates doesn't matter, but this has to be the first. Okay, so this one is wrong. So it's two or more. Okay.
14, 12.
Now do the math, so 5 to 20. No.
and-
Yes. All right, are we ready to talk about it? No. Not ready. Are you ready? Ready? Randy's being dramatic. All right, so out of our choices, A, B, C, D, E, which ones or one did you think were? A and C. Why A and C? I don't know, I just figured it out. All right, before you decided, you need to make sure this was written in coordinate form. So the first thing you should have done is rewrite your linear as a coordinate form, which means that it's AX plus BY. So we have 3x minus y, comma 2x plus 2y. Once I'm in coordinate form, I now can create my matrix transformation. Your matrix transformation are all your coefficients, right? Only the coefficients. So now, in matrix transformation, we should have had, I didn't mean to put it there. So we have t, x, comma, y. And that equals 3, -1, 2, 2, and then our x, comma, our y's, right? Yes? All right, now I have 3 points to transform. So based on what we have here, which choices again? A and C. So you could have either used A or you could have used C. Either way, it's going to come out to the correct situation. All right, did anyone complete the operation?
Yeah.
What is my matrix that I created?
1/6. 14/12. And then 2/12.
Okay. How do you feel? Okay, if you did A, what the calculator is doing for you, even though you wrote all 4 out, the calculator is only multiplying 2 at a time. Does that make sense? So it did the first 2 matrices, and it'll do the next one, and then it'll do the next one, and then that's how you end up with your output. Okay. Yes. Okay. Practice 4. The linear transformation that we have here is 1, 0, 0, 1 is applied to the vertices of the triangle ABC. Okay. The vertices of the triangles are ABC are represented as a single matrix: -1, -1, 2, -4, 4, 3. What is the image of the vertices of the triangle represented? So if I wanted to find this, this is a problem written as a format, in a different format than normal, right? But based on what we read, all of what are we doing simply? We're multiplying. We have to remember it's our transformation times our points, right? Our coordinate points. So even if it's not given to you in a straightforward format, you need to be comfortable with seeing, okay, all I'm doing is multiplying. So we have -1, 2, 4, -1, -4, 3. And I could do this by hand. I could do it with the calculator. So 1 times -1 is -1. 0 times anything is going to be 0. So that one is done. Does that make sense? And you can keep going through. So I have 1 times 2 is 2. 0 times anything is going to be 0. I have 1 times 4, which is 4. 0 times anything is 0. So I've done all of these. Now I'm going to do the second row. 0 times -1 is 0. 1 times -1 is -1. 0 times 2 is 0. You didn't see that. 1 times -4 is -4. 0 times 4 is 0. 1 times 3 is 3. So my output is going to be
the exact same thing.
Oh my gosh. I have -1, -1, 2, -4, and 4, 3. The reason why this happened is because this is called our identity matrix. Okay? Just like when you are adding and subtracting with regular numbers, you have 0 and 1. That means when I'm adding, if I add 0 to anything, is it going to change that number?
Nope.
No. If I multiply 1 by anything, is it going to change that number?
Nope.
No. This is your matrix that does that. Okay? So if I ever have this transformation, I know that my output is going to be its self. Does that make sense?
Yeah.
And this is called our identity matrix. Okay? And that concludes your homework tonight is our exit ticket. Okay? It's posted on your Canvas. And you got this, except now you have a pentagon. All right. Oh no, 1 extra pair. The horror.
I know.
I have to do one thing in my notebook.